we're going to look at solubility and energy, but actually just energy today. We're going to leave out solubility due to online learning kind of cuts in content. So you can skip all of page 21 in your notes, and we're going to start about halfway down page 22. Our goal is to be able to explain the energy changes occurring in an endothermic or exothermic process. So it's difficult to predict whether the dissolving of a solute will be endo or exothermic because we can actually only observe the effects of the surroundings. The dissolving of a substance is a physical change where the bonds of the solute are broken to produce ions or molecules. The solute molecules or ions then become attracted to the solvent particles. All right, what does all of this mean? So when I put something into a solution of water, and let's say I have NaCl. So I have an Na, NaCl minus, and of course our crystal continues. So when I put this in water, the positive and the negative break apart. Okay, they become separated. This process of separating those ions either releases or absorbs energy. But I can't see those molecules, nor can I, or there's ions. I cannot measure the energy from those directly. However, I can measure the temperature of my solution, and this temperature change of the water, aka the surroundings, tells me what's happening with those ions. If my surroundings get warm, the ions must have given off energy. If the surroundings get cooler, they must have absorbed energy from those surroundings to be endothermic. So the dissolving of a substance is a physical change, meaning I can reverse this simply by evaporating the water. The bonds of the solute are broken. So we separated these two ions, breaking their ionic bonds. The solute molecules or ions then become attracted to the solvent particles. We know that the partial negative of water, aka oxygen, is going to be attracted to the positive ion, and the hydrogens, the partial positive in water, are going to be attracted to the negative ions, and this is our ion dipole attraction in this case. Okay, breaking bonds requires energy. Okay, or energy must be absorbed to break bonds. Otherwise, everything would like spontaneously fall apart and release energy and get hot, and the world would be on fire. I mean, that might not be that drastic, but when I am breaking the bonds in an ionic solute, I am breaking ionic bonds. Remember, I can call ionic bonds electrostatic bonds. So I have to separate the positive and the negative ions. In a molecular solute, so if I have sugar, for instance, I don't break the bonds apart, the covalent bonds. I must break the intermolecular forces. Between molecules. So these would be like our hydrogen bonds, dipole, or London dispersion forces. Now, when water is used to dissolve things, all of the water molecules are tightly packed together. But we end up having to fit solute molecules in between those water molecules. So we have to break some of the bonds holding water's molecules together. So we must break some hydrogen bonds. Forming new bonds releases energy. So once we've broken them apart, new bonds form. Okay, these happen in pairs. So we break bonds and new bonds are formed. So when an ionic compound is dissolved in water, we kind of use that as an intro example here, that forms ion dipole attractions. So the ions and water molecules. In a molecular solute, Same thing's going to happen, except it's not an ion. They are forming intermolecular forces or intermolecular bonds between the solute and water. We're almost always going to be dissolving in water here, so we can use that. So solute in water or solute and solvent if it wasn't water. The overall energy change in the dissolving process is the net sum of the energy absorbed and released. Well, what does that mean? So if more energy is released than required, so we are releasing energy. Releasing energy is an exothermic, so I'm going to say it's a negative. So more energy is released than required. So maybe it required a little bit, released a lot. Overall, there's still a net release of energy. So the net sum is kind of what is the difference. Okay, so overall. So if more energy is released than required, the overall process is still releasing energy. It is exothermic. Okay, if less energy is released, so a little bit is released and a lot of energy was required, overall, there was a net requirement of energy. So this process is endothermic. Okay, so let's use all of this information to explain, using bonding and energy, why a beaker feels warm after dissolving sodium hydroxide in water. So our surroundings, the solution, are getting warm. If that's the case, we must be having an exothermic reaction. Okay, and we note that we are dissolving sodium hydroxide, an ionic compound, into water is our solvent. Okay, so we need to discuss three different things. We need to talk about which bonds are breaking, which bonds are forming, and the overall statement of what's happening. Okay, so which bonds are breaking here? Well, we need to break the bonds within the sodium hydroxide. So we are breaking the ionic bonds within the NaOH solid. Okay, we also must break some, not all, a few hydrogen bonds between water molecules. And both of these processes require energy. Okay, so breaking bonds requires energy and therefore is overall endothermic in that process, not the overall dissolving of sodium hydroxide, but breaking those bonds are both endothermic. Okay, which bonds form? Well, the Na plus and OH minus, so our ions, form dipole and ion-dipole interactions. With water molecules. Remember, forming new bonds releases energy. So this is an exothermic, whereas this one was endothermic. All right, overall, I know that the water became warm. Okay, so overall, it requires less energy to break bonds than the energy released forming new bonds. And the process is exothermic. All right. Make sure you have something like this in your notes. You must always talk about which bonds are breaking and what that requires or releases in terms of energy. You must talk about the bonds forming and what that requires or releases for energy. And you must make an overall statement of which process gives off or requires more energy.